Hey guys, my name's John Grimsmo and this is Knifemaking Tuesday, week 44. I know it's been many weeks since our last video and I apologize for the delay, but we're back in it now. And we've got a lot of neat stuff to film and show and do in the next little while. So this week, actually the past few weeks, in my spare time, I've been working on the Tor, which is our new fixed blade that we're working on for the Tormach class that we're hosting. So I've been designing that knife and designing the fixture required to make that knife. And pretty much the whole day today I've been designing that fixture and buying some nuts and bolts and metal and stuff. And I'm going to start on that project tonight. As you can see, it's winter is setting in. It's middle of October already and it's kind of getting close to freezing. Sucks. I like summer. So this is some of the metal that I got. This is a 1/2 inch steel plate. I think it weighs around 15 pounds. 15 inches wide by 6 inches tall. And this is going to be the fixture that I'm going to start with to make my Tor. It's going to be able to do the blade and both handles sort of in one fixturing. The interesting thing about this project, about making the Tor, is that I get to prototype it at home, but I have to make a fixture that I can bring with me to Tormach to host the class with and plug it into their machine. So I don't want to make it so specific to my machine and my setup. I want it to be easy that I can bring it there and plug it right into their machine, no problem, and run the code exactly as I've tested it. So that's been fun, trying to figure out how to do that quickly and easily. Fun for a nerd like me. Believe it or not, I spent a lot of time, way too much time, figuring out what screws I'm going to use to attach the handles to the side of this knife. So this guy here is pretty much the only fixed blade that I have. One of the first knives I ever got, thank you Uncle Dave, when I was 11. As you can see, this is pinned in place. A very common way to do fixed blades, not the way that I want to do it. I want the handles to be removable, replaceable, upgradable, customizable, superfiable. So I want bolts to be able to go through there and not only create clamping force, but also create alignment. So I don't just want to use a plain old screw. And also the metal isn't thick enough to have two screws, touch the tips. Or otherwise you've only got a few threads per screw. So I want to use something like a chainring bolt, but I kind of think chainring bolts are ugly. So I looked everywhere that I could think of, all the knife suppliers, all the industrial fastener catalogs. We're talking McMaster, MSC, Enco, KBC, Fastenal, everywhere I could think of, trying to find something that works. Believe it or not, Fastenal did actually have something that's pretty cool. Okay, so it's a little barrel nut like that. It's got a very thin hex head on the back, which is cool. That'll prevent it from rotating. It's tapped for, I believe, 1032, and they have them in all these different lengths. They're not bad. They're like 60 cents each or $1.30 each. I don't remember. I think $1.30 each. That sounds familiar. Fastenal part number is that, if you're ever curious. The cool thing about these is the length that I bought would actually work quite well for the knife that I'm making, to go through both handles, through the tang of the knife, through the other handle, and be able to use just a button head screw on the other side. The downside to it is that, and this isn't a big thing, but you got a button head screw on one side and a hex head on the other side. It's not an even look, but it's not a bad thing. The other downside is to mill a hex. You have to either use a very, very tiny end mill to be able to get into the corners, or, I don't know what the term is, but plunge the end mill far into every corner, so it's almost like a star shaped as opposed to a hex. And that creates extra look disadvantages, It's not a crisp hex. It's a hex with these big bubbles on every corner. And that would work. Not complaining too much. However, what I finally found after lots of searching on the USN forum, there were a few posts mentioning a online store called Monkey Edge that sells these bolts. Now Monkey Edge is primarily known for just selling custom knives or high-end production knives like Chris Reeve, Hinderer, Strider, etc., as well as customs. They don't sell parts, but apparently they got a run of screws made for themselves, like they commissioned the run themselves, and they're fantastic. Check this out. Alright, here's the bolt that they have. I love a lot of things about these. It may seem weird that I'm getting excited about a screw, but that's what knife makers and maker of things like to do. They're nerdy like that. Don't worry about it. I love how they're black. That's awesome. I love how both heads are exactly the same. They both have a hex head, 3/32 hex in it. That's cool, so you get an even look side to side. They're 416 heat-treated stainless steel, so they're not going to rust. They're really good quality hardened steel. The tolerances are pretty good, plenty good enough for what I'm using it for. I don't think I'd use it for a pivot. It's not quite tight enough for that. The consistency between the run. But for bolting handles on, I absolutely love them, and I'm super happy with them. They cost all of $2.50 for a pair. And you get a bulk discount if you order 50 or more. So I did. I ordered 50 units, and even with shipping, with fast shipping, which was $17, you know, it was still less than $2.50 a pair in the end. And they came in a day and a half since the day I ordered it. I could not be happier with the service and the quality of this thingy. So all you knife makers out there, just keep an eye out for these. You know, if you have a use for them, use them. That's all. Okay, screws are figured out. I literally spent days and days trying to figure out what screw I wanted to use, and super happy about that. Okay, next choice was steel choice. Now the steel choice for this knife was up in the air. I originally kind of wanted to use a stainless steel just because my folders use stainless steel, and it's kind of what I'm used to working with. I didn't really think about carbon steel much at all. But through several multi-hour long conversations with Chuck Bybee from Alpha Knife Supply, awesome guy, awesome store, he sort of leaned me towards the carbon steels, and specifically 5160. You know, I showed him the prototype rendering of the Tor, and he said, you know, it looks like a camp utility knife. The thickness you're going for, 5/32, means it's going to be kind of a little bit of a beater knife, you know. You want a steel that's got really good toughness, good edge holding, and it's just going to take a beating and keep smiling. You don't want an edge that's going to chip very easily. You know, people are going to be batoning with it and splitting logs and all kinds of stuff. So you want something that's going to be really tough, as well as being easy to machine, because, you know, I'm machining it on the mill. I'm not grinding it by hand. That's just the way I do it. So we settle on 5160, which is a carbon steel. Pretty good properties, very affordable. Takes a really easy heat treat, and it's just a great all-around steel. He said a lot of guys who do the American Bladesmith Society, their test to get their ABS certification, most of the guys do it from that steel, because it goes through some pretty rigorous testing for that test. Like, you have to basically be able to bend the knife in half without it breaking and have it spring back to straight, and, you know, chop a 2x4 in half and still whittle hair, or still shave your arm. So it's pretty good steel, and it, many other reasons, makes it perfect for what we're trying to do for this class. In the future, I might make the knife with other steels, with stainless, with Damascus, whatever, but for right now, for this class, I think it's going to be perfect. So the problem with that steel is, as far as I can tell, you can only get it in hot rolled finish. Alright, the difference between hot rolled and cold rolled, I don't have an easy example of hot rolled here, but this little chunk of steel is cold rolled. Notice how the edges are very square, the face, the surface is very flat, you know, pretty nice looking. It's just a nice looking piece of steel. Cold rolled means when it's cold, it's just squished through a bunch of dies, so it's perfectly flat. Hot rolled means when it's hot, it's also squished through dies, but it leaves the mill scale on it, and it's really chunky and nasty and rough and kind of ugly. Nothing you want to sell or use, and it takes a lot of finishing. And it usually comes in really weird thicknesses, you know, when you get down to the 1,000th of an inch. Whereas cold rolled is pretty much plus or minus a few thousandths. Hot rolled is like all over the place. This steel, I believe I can only get it hot rolled, but I found a supplier that has it in stock, except it's way thicker than I need it to be. So I either have to send it out to get it surface ground down to the 1/5/6 thickness that I need, or figure out how to do it myself. So for this run of blades, I'm going to buy the steel in America. I'm going to have it shipped to Great Lakes Waterjet to have it waterjet cut into pieces. And he suggested that since I'm milling everything, I might as well utilize the mill to surface the steel to the thickness that I want. One trick to do that is, here's a Norseman blade that's already been waterjet, and I mean this is pretty much finished. But one trick is to imagine if you can clamp this from the side, just from the side, so that nothing protrudes above the surface. And you can take a face mill, like this is a 2-inch face mill, and you can just go, you know, face it. Just face it right off in one clean pass. And then a light finishing pass, just to give you a good surface finish. And then flip the blade over, clamp it again from the edges so that nothing's protruding up, face it again, then you're good to go. So the tricky bit is now clamping it from the side like that, in a very repeatable, very usable manner. And since it's a waterjet piece that's all weird shaped, it's not a square, so I can't just use my vice jaws. So the trick to do that is produced by a wonderful company called MiteeBite. They make these awesome clamps called Pitbull clamps and Talon grip clamps. And if you're a machinist, you probably know exactly what I'm talking about. You can see the profile of them there on this guy. And they have a countersunk hole that goes through the middle, so a bolt goes through the top and threads into the fixture. And on the right side here is kind of the foot. So it digs into the fixture that way, and the bolt sort of arcs it downwards. And the little tip of it, it's got a little knife edge right in front of my thumbnail there that will bite into the workpiece and dig in really good and hold. Apparently, these hold 650 pounds of force, of clamping force each. You can see it's basically a little square of steel that has little cutouts on the side. Same concept as the other one, sort of. They bite into the workpiece. And I've got them mounted in some aluminum soft jaws here. I got these from monsterjaws.com. Their website basically just takes you to eBay, but these things are awesome. They're like $8 for a pair. The aluminum itself costs almost that much. So I highly recommend these. I bought like 5 pairs. But this is one use for them, so I milled a slot there and drilled and tapped holes for M5 screws. So another cool thing about this system, this Talon grip system, is that to clamp your workpiece, I mean, it's just like a vise. You unlock the vise, and the jaws open up wider. And then to tighten it, you just clamp the vise like so. But then the teeth bite into the part and create an immense gripping force. Whereas with a normal vise, you just have, you might use parallels or something to space your workpiece up. but then you're just holding onto the sides of the part with very flat faces, and the part can slip out. I've had it happen. But these grippy things are awesome. There's a little shelf here and a shelf here that your workpiece rests on, and the teeth grab onto it with only 1/16 of an inch. Like, this is a 1/4 inch thick, and you can see how thin that is. So I mean, I could face this down to really thin if I want. I have a lot of area sticking out that I can play with, you know, to machine all around, do all faces except for that 1/16 of an inch. And then if you want to, you could flip it over again and face off that 1/16 of an inch, and now you have a completely fully machined part. So that's cool. And I can also integrate these into my fixture, which is what I'm going to be doing. But in the vice jaws here, I'm going to be machining my Tor handles. This will be the first step, is to put them in here, drill the bolt holes, counterbore them, and that'll locate them onto my fixture for the next step. But yeah, so these will be really handy. Hey guys, so it's been a few days, but now I'm back at it. Finally getting ready to drill this big piece of steel for my fixture. So I'm going to lay it down on the machine. See, there's some aluminum. I've got some aluminum scrap here just to space it off the machine a little bit, so that when I drill all the way through to tap my holes, I can make the drilled hole go all the way through and not into my table. It'll just go into this sacrificial aluminum. So I have it clamped down to the table by two opposing corners. I measured the height here and then the height here, and it's about 3.5 thou higher here because it's tilting up, because it's only being held down by one corner, right? So it's tilting up about 3.5 thou, which is nothing for this purpose. And then I'm going to be milling a hole right here that'll pass a bolt through. So it'll be held from the center, which means it won't really tilt up when it's bolted from the center. So I used my touch probe here to touch the surface. I touched off the top corner, but then I'm also going to ream a 1/4 inch hole right about here somewhere. That'll from now on be my X0, Y0, and I'll use the probe to find that center. So that'll be this first setup, is to do that. So the first tool is a spot drill, so I'm just going to spot all my drilled holes. Hopefully everything works the way I wanted it to. Here we go. Next tool is the drill bit. This guy right here. That didn't work. You can actually hear it when it punches through the aluminum. Next up, I'm going to put back in my spot tool, which is also a chamfer tool. So I'm going to chamfer around these holes just to make them look nice and not so sharp. See that shadow that the tool is making? The overhead lights aren't quite getting in there, so I got my flashlight here. I mean, the shadow that thing makes is not really a big deal most of the time, but for such a short tool, it's kind of annoying. Alright, all that stuff's done now. I've got to tap 2 holes. I'm just going to do it manually. With a hand tap here. So here's the back side of the fixture. I'm going to try something new with this fixture as a way of aligning it to the table. The two holes that I drilled and tapped now have a socket head cap screw threaded into there. Notice the head's sticking up, and the head is going to go into these slots and align it. So I move the head towards the top wall, and there's two of them, so it's pretty accurate. And that doesn't give any left to right positional accuracy, but that's what the zero hole is for, so I can just zero off of that. But it'll keep it parallel to the table, which is pretty cool. And it lets you use a smaller fixture without necessarily having to commit to these rounded diamond pins like I'm using here and here for my big fixtures. Anywho, and also this way, I know that this fixture will fit on the big machine, the 1100, but also on Tormach's 770 machine. So I can swap the same fixture onto either machine and zero it, and it'll be great. So that's kind of why I'm doing it this way. Yep, so the pins work great. I just push it forward, and it's totally repeatable that way. Like I said, not left to right, but that's okay. So the engraving turned out awesome, except I totally messed up, and I wrote down G59 P11 when I was supposed to write down P15. So I scribbled that out and engraved a new one. Also, there was a mistake here coming out of that 1/4 inch hole. I had an offset issue that I was stupid about, so a little mistake there, but otherwise turned out really good. So here it is bolted to the table. I think I'm going to countersink these into the table more, or into the fixture more, because I don't like them sticking out so high. That's sort of counterproductive to what I'm trying to do for a lot of this fixture in the future, and I'm going to have to chop these bolt heads off because they're too long and I don't have any shorter ones. But this way of aligning the fixture works really good. I got that idea from my buddy Michael, the eclectic angler. He makes really cool fishing reels. So thanks for that tip, Mike, and hopefully it works out really good. Alright, here I've got my probe with the that zero hole right there. So I just have to jog it around until it's somewhere in the middle, not just so it's not touching the walls, basically. Put it down into the hole, hit go. So it goes left to right, it touches each wall, goes front to back, and then it goes left to right again, just because. And there you go. Alright, so making awesome progress on this thing finally. I just did an operation where it takes a 3/16 end mill and it pockets these circles. They look like drilled holes, but they're actually a little bit bigger, to fit the monkey edge bolt that I'm using right here, because that will help align my handles onto the fixture. And the first time I milled these, the bolt didn't fit, so I just milled the exact same program again, which basically gave it 2 finishing passes instead of just 1. And now the bolts fit in there like perfectly. Super perfect. So I wrote a little note in my code to go back in my program and make sure it's got 2 finish passes next time, in case I ever have to make another fixture, or just so I know for next time. So now I'm going to throw my chamfer mill back in, because it's going to chamfer both every single hole and all these rectangular pockets and everything. So, you know what's funny? And not in a ha-ha funny, but in a this milk tastes funny kind of funny. I'm an idiot. I just ruined this whole thing, and I'm on the very last operation. Alright, this is a 440 tap. I'm trying to tap that hole inside the rectangle, and use your imagination. Is that hole the right size for that tap? No, it's way too big. Because I'm an idiot, and when I was choosing all the holes to drill, like all these are 0.2 inch, I'm getting ready to tap for M6, I just chose those ones too. So all of these 4 holes basically, the small rectangles, are all drilled way too big, making the fixture basically useless. I mean, if you were crazy, you could like weld them shut or something and then re-drill them, but another chunk of steel doesn't cost that much. So yeah, I'm an idiot. Otherwise, it's perfect. But at least now I know how to make it, so the next one's going to go a lot faster. There's a lot of back and forth between the computer and here, trying to get this one perfect. And now that it is perfect, I need to do it over again. Sucks. That's okay though. So I'm going to the metal store. Anyway, I'm going to cut it there for this video, because it's just going to be more of the same. As always, thanks for watching. Sorry for the huge delay from the last video. I know it's been like 3 or 4 weeks. Hopefully we're getting back to a weekly video schedule from now on. So next week we'll be making blades and handles. So thanks for watching, guys. Take care. Bye.